Steganography standpoint, we found multiple ways of hiding files in formats, and we're going to show a couple of those in our demo. They are quite nicely relating to the vulnerabilities we found. Now, from the vulnerability standpoint, we found high probability of malware detection evasion. So, anti-malware scanners affected by these 15 reported vulnerabilities, with more pending, were unable to correctly process the entire archive, and therefore were missing some of the malware packed inside it. Now, there are few types of threat level you can assign to this. You can say it's very high and it's critical, because if you are at the gateway and you want to scan all the email and all the files that come to your network, you're going to want to be able to scan everything. But if you are scanning on the desktop or your endpoints, there's a low impact, because for that malware to execute, you still have to extract it, and that's where the anti-malware scanners are going to catch it. So depending on which software security product you are looking at, the impact is either high or low. Now, we're going to go over the steganography in the zip file format only, and it's achieved by modifying the name of the compressed file inside headers. So basically just by inserting a null character in front of the first letter of the compressed file, you are able to hide files from you, but that only works for WinRAR, and other processors will show up empty file slot. Now, there are other ways you can successfully hide files from all archive processors, such as decreasing the number of packed files inside the header. So if you have the last file packed, you just decrease the number and the last file will not be registered. And we can use extra fields in the zip file documentation to camouflage some of the header data. And we can move the central directory to hide data from the start of the archive. And we can also inject new data, of course. Now, what are the implications of this steganography point? Data can, of course, be hidden in the zip archive. But data can also be hidden in the OOXML file format, which is the OpenOffice XML file format used by Microsoft Office, which is basically just a zip archive containing lots of XML files. So since this applies to zip archives, it also applies to the Microsoft Office file format. Now, this is what's important, because if we have injected data inside of it, it can self-destruct, and it can do that by the actions performed by the user. So if I would to hide a file inside a Word document, and you would to open that kind of file, Microsoft Office would tell you this file was damaged. Do you want to repair it? And as soon as you do, the file, the injected steganography data is gone. The same can be achieved by the antivirus software, because if you pack a malware inside it and additionally hide some stego data inside it, so if you're inspecting that kind of file and you have an antivirus working, it's going to say, oh, I found a malware in this, do you want to clean it? And as soon as you do, the data is gone. So from the forensic standpoint, if you are inspecting the data, you must make sure that no other tool is going to interfere with the evidence, of course. Now, the implementations we found, because we didn't really invent this, and we didn't want to create new problems, there are some implementations you can see on the internet. There's Zip Steganography by Karina John. It's published by CPOL license. It can hide multiple files inside the zip archive, which is stored just before the central directory. It can also encrypt files with the password. And there's another solution we found. It's called ZJMask by Vincent Chu. It's a freeware tool. It can only hide one file inside either zip or a JPEG file. It does that by prepending the file to the archive. It also damages the file in the process, but it can be decompressed generically. So if you use software such as WinRAR, you will be able to decompress such an archive. But since that's not a valid archive, we really didn't want to bother with that. Now, we're going to disclose the 15 vulnerabilities we found. Now, before we do that, I just want to say that we acted responsibly this way, and we disclosed all these vulnerabilities to the affected vendors with association with CertFI. So let's go over them. Most important thing is, during our investigation, and the stuff you're going to see now is mostly related to zip, but there's at least one vulnerability for each of the affected file formats. So most of these are zip. The first one is caused by extensive header modification. So what we did here is we wanted to create our own steganography implementation just to test our tool, and in the process we successfully have hidden the file, but we did extensive modification to the file header, and that's what caused the problem with some security software vendors. So here's what we did. We used central directory fields to store some information which broke the file format intentionally, and replaced the first name of the file with 0 and erased the local header content. So that's why archive word processors in antivirus software didn't really work right. The second one was, anyone could have thought of this, but this was a cool thing to try. We partially protected an archive with a password. So we protected the first file, which is just an image with a password, and all the other files in an archive weren't protected with the password. So you can extract them normally, and some antivirus vendors wouldn't correctly process this archive. They would find the first file that was password protected, and they just thought the whole archive was. Now this one, next one is this weird hybrid file method we talked about. So this is pretty a neat thing to do. What we did is we compressed a config sample, and we created a self-extracting executable with a zip, and no antivirus in the world had a problem with this. Okay, because zip is a specific format. When you are identifying the zip archive, you are going from the end of the file. So what we wanted to do is just append another zip file to the end of the SFX file, and that's why when you are scanning the archive, you will be able only to see the last file, which was appended, and the SFX content, which was extracted normally when you started the SFX program. The compressed content was malware, of course, and some antivirus vendors went, and this was the correct way for scanning the file from the end, and that's why they only found the clean archive appended. Now, this one is one of the stable implications to the zip archives. So there's an extra field behind every central directory entry in the zip file header, and if you use this data, which isn't really commonly used by any of the archive processors, you will be able to hide some data behind it. So by damaging the header like that and just cloaking the next item in the zip header, we were able to successfully hide malware, because antivirus software would just skip over that because they weren't processing the extra field correctly. Now, another weird file format example is, which one I mentioned earlier, is where we added some fields to the zip archive, which made it look like a zip64, but no archive processor thought it was zip64. It processed that normally. So that was an error with identifying the file format itself. Now, next one is realigning the file to the 40 hex bytes, and realigned is quoted because we really didn't realign anything, we just prepended the bytes, and that actually breaks the archive. But since the zip file format has both central and local directories, you can also extract this data generically, and software which does that is WinRAR, and it was the only one who was able to do it. And that, of course, even though this isn't a valid archive, if it's still extractable by at least one tool, antivirus vendors want to support that case as well. Now, we use the file comment field, which is exactly the same like the extra field. It's just additional data behind every entry in the header. And since this is rarely used field, and we haven't seen any of the files using this, some antivirus vendors were just confused about where the next header is and didn't really scan the whole archive. The next one is also a weird kind of format. It relates to bad compression algorithm, but it's not really bad, because specially crafted zipx file, which was introduced in WinZip 12 version, it has a new compression for the JPEG files themselves. So if you compressed a single image, which is a JPEG with this new zipx version, and you just rename the file to zip and use any other tool in the world to add another file inside that particular archive, we still have a valid zip file because all headers are the same between the new file